All right, so moving on to the next one. So once we know what the energy is that's released, we can use it to go and find some other things. We can find characteristics of the radiation. So here it says find the frequency. We've got a formula on our formula sheet, and it's also in the book. That says that your frequency comes from your change in energy divided by h. So we remember we had before that h times frequency was a way of finding energy. This one's basically just going back around the other way. What it requires, though, is that we know the change in energy. And again, if you went and found the different numbers for hydrogen, we can take a shortcut here. But if you don't have those numbers, then you don't know what E4 and E2 are in order to subtract them. So, like I said, it's good to find those different E numbers, write them down. They can't change for hydrogen. But otherwise, we just run through and find them manually. So negative 13.6 electron volts, technically 1 squared, but that's not going to do anything, so I'm going to leave it out. And then we get 1 over 4 squared minus 1 over 2 squared. So 1 over 2 squared is 1 over 4, which is 0.25. And then 1 over 4 squared is 1/16, which is 0.0625. And then we're trying to subtract those. So the negative 13.6 electron volts end up being multiplied by negative 0.1875. So we see again, hopefully negatives will cancel. So then this energy released is 2.55 electron volts, which is now a number I can plug back over here. You also see when we had Planck's constant earlier that had electron volts in it, that's going to cancel electron volt energy that we're looking at in this one, and that's going to make that really handy. So change in energy, 2.55 electron volts. Then Planck's constant, 4.14 times 10 to the negative 15. And this is electron volts times seconds. Now for these units, the electron volts are going to cancel the electron volts. But because the seconds are on the bottom of this fraction, then that means that they turn into hertz as part of the final answer. And then that final answer is 6.159 times 10 to the 14 hertz. So also could be written as 615.9 terahertz, because terahertz are often convenient for visible light.